exist reactants. Objectives: distinguish limiting reactant from exist reactants in a chemical reaction. Show the use of the limiting reactant in a stoichiometric calculations, and calculate limiting and exist reactant in a chemical reaction. Our learning competency is determine the limiting reactant in a reaction and calculate the amount of product formed.
What happened? In a perfect world, we would have exactly as much of each reactant that we need to convert everything to product. However, in real life, it is much more likely that we cannot be represented by a ratio of well-defined natural amounts of reactants. How do we predict how much product is going to form? This activity will walk you through the concepts of limiting reactant and excess reactant. In a dance contest among boy to girl pairs, if there are 6 girls and only 3 boys, then only 6 boy-girl pairs can compete. There are girls will be left without a partner. The number of the boys thus limits the number of girls that can join the contest.
Limiting reactant or limiting reagent is a reactant in a chemical reaction that determines the amount of product that is formed. The reason there is a limiting reactant is that element and compound react according to the mole ratio between them in a balanced chemical equation. So, for example, if the mole ratio in the balance equation state it takes 1 mole of each reactant to produce a product. 1:1 ratio, and one of the reactant is present in a higher amount than the other. The reactant present in the lower amount would be limiting reactant. When chemicals are mixed to undergo a reaction, they are often mixed in a stoichiometric quantities. That is, in exactly the correct amount so that all reactants run out or are used up at the same time. To clarify this concept, let's consider the production of hydrogen for use in the manufacture of ammonia by the Haber process. The Haber process, also called the Haber-Bosch process, is an artificial nitrogen fixation process and is the main industrial procedure for the production of ammonia today. Ammonia, a very important fertilizer itself and a starting material for other fertilizers, is made by combining nitrogen from the air with hydrogen according to the equation N2 times G plus 3H2 times G. We can also rewrite it to 2NH3 times G. From the valence equation, we know that each N2 molecules requires 3 H2 molecules for the reaction to occur. Thus, the required H2 or N2 ratio is 3 H2 or 1 N2. There is not enough hydrogen to react with all the nitrogen. That is, the hydrogen will run out first, leaving some unreacted N2 molecules. Consider the reaction between aluminum and chlorine. 2 aluminum times S plus 3 chlorine 2 times G. We can also write it to 2 aluminum chlorine 3 times G. This shows that 2 moles aluminum react with 3 moles chlorine 2. The mole ratio aluminum to chlorine is 2:3. If the ratio of the available substances is 3 of aluminum, 3 moles chlorine, then there is an exist 1 of 1 mole aluminum. Mole reactant available: 3 mole aluminum, 3 mole chlorine 2. Mole reactant consumed: 3 mole aluminum, 3 mole chlorine. Mole reactant not reacted: 1 mole aluminum, 0 mole chlorine 2. When the reaction is allowed to proceed, only 2 moles aluminum will be consumed and 1 mole will remain, while all the chlorine 2 will be used. The limiting reactant in this reaction is chlorine 2, while aluminum is the reactant and exists. In order to determine which reactant is limiting, the amount of product from each of the give amount of reactant is calculated. The reactant that gives the smaller yield is the limiting reactant.
Sample problem number 1. In an experiment, 5.00 grams aluminum is heated with 25.0 grams sulfur to form aluminum sulfide. The equation for the reaction is Al times S plus S times S. That is the reactants. Al2S3 times S is the product. Unbalanced chemical equation. A. How many grams of aluminum sulfide will be formed? B. How many grams of X size reactant will remain? Given. Mass Al equals 5.00 grams. Mass S equals 25.0 grams. Find A. Mass Al2S3. B. Mass excess reactant. Solution. A. Step 1. Write and balance the equation for the reaction. 2Al times S plus 3S times S. That is the reactants. Al2S3 times S is the product. To balance the chemical equation, write only a number coefficient before any substance. Step 2. Identify the molar mass of the following. Aluminum times A minus 27 grams or mole. Sulfur times S minus 32 grams or mole is the atomic number. To get the molar mass of an element, identify the atomic mass from the modern periodic table of elements. Step 3. Identify the limiting reactant by calculating the amount of product formed from each of the given amounts of reactants. Using 5.00 grams Al, molar mass is 27 grams or mole. Mole Al equals 5.00 grams over 27.0 grams or mole. Al equals 0.185 mole Al. From the balance equation, 2 moles Al forms 1 mole Al2S3. Therefore, mole Al2S3 equals 0.185 mole Al times 1 mole Al2S3 over 2 mole Al, 0.093 mole Al2S3. Using 25.0 grams as molar mass, 32.00 grams or mole. Mole S equals 25.0 grams over 32.0 grams or mole, 0.780 mole S. From the balance equation, 3 moles S forms 1 mole Al2S3. Therefore, mole Al2S3 equals 0.78 mole S times 1 mole Al2S3 over 3 mole S, 0.260 mole Al2S3. 5.0 grams Al produces less Al2S3 than 25.0 grams as aluminum, therefore is the limiting reactant. Step 4. Using the value for the number of moles of the limiting reactant, calculate the mass of Al2S3 formed if its molar mass is 150.0 grams or mole. Mass Al2S3 equals 0.095 mole times 150.0 grams or mole equals 13.9 grams. B. Solve for the amount of excess reactant by determining the actual amount of S that reacted with the limiting reactant Al. Form the balance equation. 2 moles Al react with 3 moles S. Therefore, mole S equals 0.185 mole Al times 3 mole S over 2 mole Al. 0.278 mole S. Since the available S is 0.780 mole, then the amount of S that has not reacted is mole S not reacted equals 0.780 mole minus 0.278 mole equals 0.502 mole. Calculating the mass of excess S. Mass S equals 0.502 mole times 32.0 grams over 1 mole equals 16.1 grams. Solution. Since mole is already given, we can directly convert mole C6H12O6 to mole CO2 using the stoichiometric ratio of C6H12O6 and CO2 Moles of CO2 equals 0.5 mole C6H12O6 times 6 mole CO2 over 1 mole C6H12O6 equals 3 mole CO2. Convert mole CO2 to mass CO2 using its molar mass mm equals 44.01 grams or mole. Mass of CO2 equals 3 mole CO2 times 44.01 grams CO2 over 1 mole CO2 equals 132.03 grams CO2. Therefore, 132.03 grams COR produced from 0.5 moles C6H12O6. 3. Consider respiration, one of the most common chemical reactions on Earth. C6H12O6 plus 6O2 times 6CO2 plus 6H2O energy. What mass of carbon dioxide forms in the reaction of 25 grams of glucose with 40 grams of oxygen? Solution. When approaching this problem, observe that every 1 mole of glucose C6H12O6 requires 6 moles of oxygen to obtain 6 moles of carbon dioxide and 6 moles of water. Step 1. Determine the balanced chemical equation for the chemical reaction. The balanced chemical equation is already given. C6H12O6 plus 6O2 is the reactant, and the 6CO2 plus C6H2O is the energy and product. Step 2. Convert all given information into moles, most likely through the use of molar mass as a conversion factor. 5 grams times 1 mole over 180.00 grams equals 0.14 mole C6H12O6. 40 grams times 1 mole over 32.00 grams equals 1.25 mole CO2 is the mole of the reactants. Step 3. Calculate the mole ratio from the given information. Compare the calculated ratio to the actual ratio. A. If all of the 1.25 moles of oxygen were to be used up, there would be 1.25 times 1 over 6 or 0.208 moles of glucose needed. There are only 0.14 moles of glucose available, which makes it the limiting reactant. Number 1. 25 mole CO2 times 1 mole C6H12O6 over 6 mole CO2 equals 0.208 mole C6H12O6. B. If all of the 0.14 moles of glucose were used up, there would need to be 0.1388 times 6 or 0.8328 moles of oxygen needed. Because there is an excess of oxygen, the glucose amount is used to calculate the amount of the products in the reaction. 0.14 mole C6H12O6 times 6 mole CO2 over 1 mole C6H12O6 equals 0.83 moles O2. If more than 6 moles of O2 are available per mole of C6H12O6, the oxygen is an excise and glucose is the limiting reactant. If less than 6 moles of oxygen are available per mole of glucose, oxygen is the limiting reactant. The ratio is 6 mole oxygen per 1 mole glucose or 1 mole oxygen per 1 over 6 mole glucose. This means 6 mole CO2 or 1 mole C6H12O6. Therefore, mole ratio is 0.83 mole O2 or 0.21 mole C6H12O6. This gives a 4.004 ratio of 0 to C6H12O6. Step 4. Use the amount of limiting reactant to calculate the amount of CO2 or H2O produced for carbon dioxide. Produce 0.14 mole glucose times 1 over 6 equals 0.83 moles carbon dioxide. Step 5. If necessary, calculate how much is left. Excise 1.25 mole minus 0.84 mole equals 0.4172 moles of oxygen left over.